Okay, so now we're going to look at linear inequalities. So we've learned about linear relationships. We reviewed those last week. Linear relationships, remember, is when we're graphing things that are y equals mx plus b. So we're going to be still doing some of those steps, but adding one more level. So we're going to follow the same steps as we would graphing normally. So we're going to graph the y equals what mx plus b. So we're going to graph the y-intercept first and then use that y-intercept and find the slope to graph the line. The only difference in a linear inequality and a linear equation is that it's going to look something like this. Y is less than negative 2x plus 5. So see how it has this symbol? That makes it an inequality. So there's a few different things we need to know. Remember when we were graphing, we were solving inequalities and we had to graph them on a number line and we used an open circle and then we pointed it certain directions. So we're going to kind of do the same sort of thing, except it's going to be on a graph. So if we have a less than or a greater than sign, they're going to have a dashed line. So think of it as an open circle dashed line. They're not solid. They're not complete because it only includes things that are bigger or less. It doesn't include what actually is, what's equal. Then greater than or equal to and less than or equal to are going to have a solid line. So think of it as your closed circle. That's as close as I could make it. And that doesn't even look like a circle. It looks like some weird type of flower, but it's fine. So it's going to have a solid line. This is going to be dashed. That's how you're going to graph it. So those are two things you need to know. Now think about when we had less than or equal to, remember we pointed our arrow this direction. So think about if you have a graph, you're going to shade it below the line. And I'm going to show you an example of what that looks like in a moment. But because y is going to be less than any of the x values, then we're going to shade underneath the line or below the line. If we have greater than and equal to, it's the same thing as going bigger. So we're going to shade above the line, below and above. Okay? All right, so let's look at an example problem. So we have y is less than 4x plus 1. So we first graph the y-intercept, and then we go up 1, 2, 3, 4 over 1 to do our next point. We know that this right here means that we're having a dashed line. So that's what the red is, the dashed line. Now the inequality, because the inequality isn't equal to, so it's a dotted line or a dashed line. It says y is less than. See how y is less than this part? So the y value is always going to be smaller. So we're going to shade below the line. Now I know it gets kind of confusing where the line is. So it's either going to be below the line or just somewhere on the side that's smaller. So look, do you see how where I shaded has smaller y values than where I didn't shade? That's because the y value is less than. That's messy shading. So this one is an example of something that has equal to. So this is y is less than or equal to x plus 2. So notice that we graphed the line. We have x plus 2. It's a solid line because we have this equal to, and y is less. So all of these y values that are less than the y-intercept is where we're going to shade. And whenever you're actually doing this, like on paper, your shading doesn't have to be perfect. It can be sloppy as long as it's very clear where is shaded and where is not. And the last example, y is greater than 2x minus 4. So here we have 2x minus 4. It does not have an equal sign, so our line is dashed. and it says y is greater than. So we shaded on top because the y values are bigger on top than they are underneath. So that's what you really need to look at is the y-axis. Look at where you're shading. If it's bigger than, then you're going to shade where the bigger numbers are. If it's less than, then you're going to shade where the smaller numbers are. But we're always looking at those y values. We're not looking at the x-axis.